I'm going to start the recording for drafting 131. First thing, we are going to review our schedule. And we're going to review homework assignment number 6 and then continue on 3D modeling. And we will issue drawing number 4. Okay. So homework 6, what is a dimension style? What is a text style? What is LT scale, MSLT scale, and PSLT scale? So these are all very important things that we need to know in AutoCAD. And this is the last time we're going to talk about AutoCAD 2D in these terms. And so this applies mostly to, well, it applies to AutoCAD 3D as well, but the way we're going to work with 3D is going to be different. So apply to AutoCAD 2D. And remember, all we're saying is when you work with AutoCAD and you start creating annotations and dimensions, you need to make sure that the annotations and the dimensions are going to print correctly on the viewports at whatever scale the viewports need to have. And for that, the first thing that needs to happen is that you need to be in control of the global variables called LT scale, right? LT scale is a global variable, and you control the scale of all line types. And so if we type LT scale and then press enter, then we can set the LT scale to whatever scale we want. Now, I typically will suggest as a best practice to set LT scale to 1. If you go to work for a company, those companies may have LT scale set to 48 or 96, which are the scale factors, or 1/4 of an inch or 1/8 of an inch equals 1 foot. And that's something that we used to do in the past. Set the global LT scale factor to the scale of the print. In that way, all line type scales are going to be printing as intended when the line type was invented. But that creates a problem because it doesn't allow us to really control the line types. It just sets it to that. And then also it creates problem with other variables we're going to talk about. So in my opinion, if you set the LT scale to 1, then you have more control. Although some companies may do it different ways, right? And so that's all I'm trying to say. And the LT scale is the variable that controls globally the line type scale of all the different line styles that you may have in your drawing. So we'll set that to 1. Then, of course, remember that we have PSLT scale, and we talk about this in CAP 1. PSLT scale is a global variable that controls the scale of objects in paper space. Not really. What it does is it controls the scale of the line types as defined by the scale of the viewport on paper space. And so when we set it to 1, as it is currently the default PSLT scale, set to 1, that's the default. What it means is that whatever scale factor I have as a global LT scale, the one that we just did, will be multiplied by the scale of the viewport. And that multiplication is what's going to define the visibility of the line types in that particular viewport. And so it could become really complex to do that. The number one in PSLT scale is a switch. PSLT scale can be set to 1 or to 0. It cannot be set to any other number. It's either on or off. If it's on, then the scale of the viewport on paper space is going to be multiplied by the scale of the line type scale on model space. And that final number is the one that defines the size of the line types in your print drawing. So as you can see, it becomes confusing. So the best practice then is to set it to 0. So that whatever you see on the model space is what you get. It does not get multiplied by the scale of the viewport. And then we get another variable called MSLT scale. This is a model space line type scale variable. And so same thing. This MSLT scale is the scale that we have for annotative objects. And that's the scale you see at the bottom right corner of AutoCAD in model space. It's a switch for that. And this switch is also 0 or 1. If it's on or 1, the line type scale, whatever it is, gets multiplied by the scale at the bottom right corner of the annotated scale, plus the scale factor of the viewport. So it becomes really, really complex here. So once again, my advice is set that to 0. In that way, what you see here is what's going to be printed on the viewports. So once again, LT scale 1, PSLT scale 0, MSLT scale 0, okay? And in that way, you have more control. That said, once again, it may be different in the company you go to work for. But if they have best practices in mind, then they'll do this. Dimension style and text style. Those are two very important annotative styles or annotation styles that we need to set up in AutoCAD, right? And so remember that anytime you start a drawing, you need to make sure that your text styles are created, always. And in technical drafting, we have 3 sizes of the text, or 3 text sizes. We have large, medium, and small. Those are the 3 sizes of text we have. And so the large size of text we use for titles in our drawing. The medium size of text we use for subtitles. And the small size of text we use for notes. Those are the 3 sizes. If you're working in engineering drawings, do you have the same 3 sizes as if you are working in architectural drawings? What changes is the height for each one of those sizes, although it's very, very close. And those you can find, the sizes for the text, you can find in the annotation and dimension standards that you have available to you in the course resources. And so titles, subtitles, and notes always are going to have the different sizes. So that's what you need to do. Now, also please notice that all text styles should be annotated so that the size and the appearance can be defined by the scales of the annotative scale and of the viewport scale. The same happens with the dimensions, right? So if I go to annotate, then I get to dimensions. Dimensions need to be set according to the discipline of the drawing that I'm working with. If I'm working for architecture, then it should be an architecture dimension standard. If I'm working for engineering, an engineering dimension standard. Both need to be also annotative. And that's it. That's all we want, right? Remember, dimension styles are a set of properties that the dimension elements will have. The lines, the arrows, the text, and the units in the dimensions need to be set so that they display properly according to the discipline of the drawing. All right, that's that. Now we're going to continue our introduction to 3D in AutoCAD. We talk about the generals last class, and now we're going to amplify that and start working on the drawing number 3. Now let's look at the assignment first. So assignment number 4, or drawing 4, is a drawing that we are going to, we're going to work a long time in this project. Let me check again the schedule so that we can see exactly how long we have. So drawing 4 is due on April 14th. So as you can see, it's about a month and a half. But remember that we have a spring break in between, so that's 1 week. And so it's about a month that we have to work on this drawing. But for this drawing, we're going to have a couple of reviews that are intermediate. We're going to have a first review on March 10, and then another review on March 31st. So we're going to have 2 reviews. And then, of course, the final submittal. Because I want to make sure that we do the drawing and that we finish it. So what's the drawing? Well, using your floor plans from drawing number 3, you are going to develop a 3D model of the project, the whole building or the whole project, whatever the project is. And then we're going to create also a 3D model of a detail. And as we continue to work, we're going to define more and more what these are so that you have it clear. Once we are ready to present the project as the final presentation, we are going to print on 11 and on 18 by 24, 4 views of the project, 4 views of the detail, 2 sections, and 4 elevations. All of this needs to come out of the 3D model that we are creating, this, okay? And so that's what we're going to talk about now. And remember that when we work in 3D, we're going to use a tool set that is very different than the tool set that we use for AutoCAD 2D. So we'll talk about that right now. And then we'll introduce some of these tools that we have here. The first thing we do when working with 3D modeling in AutoCAD is to open a file that is a 3D file, right? And so I already have created a drawing that I want to start, but I want to go through the process again. So you're going to do new drawing. And now you're going to select ACAD 3D, all right? That's what we want. We don't want the 2D AutoCAD, we want the 3D AutoCAD. And open. And so we get to this view of AutoCAD, right? That's the 3D view. Remember that there is a view cube here on the upper right corner that controls or allows us to control the view. We can move around and so on and so forth. There are some coordinates here, so I'm going to right click on top of this coordinate and make sure that my view is parallel. And also I am going to right click again and set this view as home. And then notice that if I move the cursor kind of upper left corner by the right corner of the screen, but kind of on the left corner of the cube, I see a little house. If I go to a view like this and I want to go back to the home view, I can click on that home icon and I'm back on the home view that I just defined, right? So that's how we navigate there. Another thing that I need to do when working in AutoCAD 3D is to actually set the ribbon to be 3D oriented. And so go to the workspace settings, bottom right corner, and you are going to select, for now, 3D basics. And you see the ribbon has changed now to have the 3D basics of the AutoCAD tools. Right, and we talk about last class that we have three main type of objects that we can create with AutoCAD 3D. Those objects are the primitives, the surfaces, and the meshes. Sorry, three type of objects, but four ways. We can select primitives for solid objects, or we can create solids using these tools along with two-line work. So we got primitives and we got a set of discrete tools that allow me to create solid objects. Then I also have surfaces and meshes. We are mostly going to be working with solids in AutoCAD, although we'll do some surfaces as well. And so another one of the really important tool when we work with AutoCAD 3D is called the UCS, right? The User-Defined Coordinate System. AutoCAD can only create geometry on the X and Y axis in 2D. So you have the X, the red line, and the Y, the green line. So if I select to create a rectangle, for example, and click, that rectangle is created on the X and Y axis. So 2D geometry is always created on the X and Y axis in AutoCAD. There's no way to escape that. And so that creates a problem for us, right? Because if I have a box, I'm going to create a little box here again. And the box has a three-dimensionality. It's got faces on the sides and so on. I'm going to change the visual style to conceptual. So we got a top, we got a side, another side. And if I rotate the cube, we got another side. I rotate it again, another side. So this box, and then a bottom size, right? I can go under, I can see from the bottom and from the top. So we got 1, 2, 3, 4, 5, and 6. We have 6 faces on this box. And by definition, if I want to create 2D geometry using this object to define that geometry, I can only create that geometry on the workplace, on the workspace defined by X and Y. And so that's where this manipulation of the UCS comes into place, right? Because I want to make sure that when I create geometry, I create it in the right place. For example, let me go here to 2D wireframe. And now wanted to create geometry on top of this box. So select rectangle and kind of create that there. Done. And now remember that from a 2D profile, I can create a 3D object by using these tools here. So I'm going to use the extrude tool and click on that object, press enter, and done. So let's go back to conceptual and see where that base drawing was created, the base rectangle. See, it was not created on top. It was actually created at the bottom on the X and Y. And so unless I manipulate the UCS, I'm not going to be able to create the geometry where I wanted to have it. Even though, and this is typical of working with AutoCAD 3D, even though it seemed like it, right? It seemed like I was on top of this top face, I was not. So I'm going to delete that. The way to then be precise about the work plane that we have is then to use this tool called 3-point UCS or all the coordinate tools that we have here. It could be rotate UCS, or it could be UCS by 3 points, by preview, by view, by face, and by object. And so the one that is more precise and easier to use is this one. This would allow me to relocate the UCS, the user coordinate system, to wherever I want. And in that way, I can always know where the X and Y are located, and then I know where to create the profiles or the 2D content that I need. So I'm going to select 3 point, and I'm going to bring my origin to the top of that corner there, the X here, and the Y there. And now I am absolutely sure that my UCS is at the top of that box. So if I create a rectangle here, and then I extrude that rectangle, I know that that's coming from the top. See? Top of that. Because I defined the UCS to be on top of that by using the 3 point. Let's do another example. Let's use 3 point, and this time I'm going to go down here. This is the X, and this is the Y. Now, the work plane is now on this side face of the object. Let's create another rectangle. And let's extrude that rectangle. go to the side view. One second, I'm gonna go back to my world and then side view. And you can see the object from the side, right? One at a time. Because I'm able to define precisely where the X and Y need to be. And so that's a fundamental concept in creating geometry in 3D in AutoCAD, because you are going to be using 2D tools to generate 3D content all the time. And to be able to place the object where I want it to start from, you need to make sure that you control the UCS properly. And that's it. Okay, so let's move on. What would be the the workflow when working with AutoCAD this way? Well, remember that I asked you to create a plan, elevation, and section views for your project, right? And so one of the things I can do is to open a 3D project like this and then bring in my 2D views. And that's another reason why the 2D views should have been created independently, one from the other, not all on the same file. And so, for example, I'm going to insert a view here. How do I, and you are all experts on this now, how can I bring in here a drawing that I previously have done, that I have somewhere in my computer? Well, I can do it many ways, right? I can do an XREF, I can do a block, and I can do copy and paste. Those are 3 ways to combine multiple drawings into other drawings. And so maybe I do that. Maybe I type XArt for XREF, and then I go and look for a drawing that I have. I'm going to look for this drawing called, maybe we do, yeah, let's do the base drawing, right? And click OK. And now click, and my base drawing is here. Zoom all, and now I can see the base drawing. Now see, very important to see that the base drawing was inserted at the X and Y coordinates. And that's great. That's what I wanted to see it, right? And so now that I have this object here, I can start creating geometry in 3D just by using that profile. And there are some tools that are going to allow me to do that. But obviously, inserting as an XREF has its pros and cons. And in AutoCAD, actually, in my case, I actually prefer to copy and paste the view on 3D. So I'm going to select this. Right click, copy, select clipboard, copy with base point. Maybe select that as the base point. And now I'm going to go here and clipboard paste. And I'm going to get rid of this XREF, although you could do XREF too. That's fine. It's just that as a best practice, I actually like to copy and paste. But there are advantages and disadvantages of both. So now that I have this plan view here, then I can apply some tools. I can apply some tools to create geometry. Can I apply extrude? Well, let's see. Yeah, I can, but remember that extrude only creates, extrude on a single line element creates a 3D face. Even though the 3D face is the right size, it's just a face, right? So I could continue to do extrude and select all of the faces, right? but C is empty inside. Even though it looks like a 3D object, it is empty. It's just faces on the outside. And not particularly interested on that unless it was required, right? Because in reality, that wall is a solid wall. And it might be in the case of your drawing. Uh, if you're creating a solid wall for the house or for a building, then you would like to have a solid element there. And so then remember that the only way to create a solid using extrude is by having a rectangle that is a polyline. So I could do this, right? I could create a rectangle. Now I have a polyline. And now I could do extrude, right? Extrude, select the polyline, enter, and now we give it a height, 8 feet. Now I can't give it a height of 8 feet, right? Because my units have not been set. So I'm going to undo, go to units, and make sure that I am allowed to enter feet and inches. Extrude again, select the polyline, enter, and 8 feet. And I just created a solid object. And it was from the existing geometry, only that I needed to create a polyline object instead of a single lines objects. Now, because you could do, because you have, I'm going to try to select these lines again. Great. Because you have this object as copy and paste, and that's why one of the reasons I do that, I could make these objects polylines, right? So I could do PE, select it, make it a polyline, and then join 1, 2, and 3. I'm not going to join that last line because actually I need to break it first. But I just created a polyline there. Now I'm going to break this line in two. So we're going to do break at point, select this line and break it there. And now I'm going to make it a PE. Yes, and join. See, now this whole thing is a polyline. And now I can extrude it. And created the wall. And so that's the workflow that I'm looking for, right? You bring your floor plan here, and then you start creating geometry in 3D with the tool of your choice. There are many tools that we can use for that. And the first one that we're talking about is called extrude. And we are using the 2D profile that we had on our original floor plan. Now let's talk about this other tool called the press pull tool. Press pull is a very interesting tool because with press pull, I don't have to convert the objects to a polyline if I want a solid. What press pull is going to do is going to identify this as a boundary. And then it's going to use that boundary as the defining boundary to create the solid. And so I am going to use this tool here. And I am going to come inside this area and see how it highlights as I glide over it. Then I click, and now the whole boundary creates this shape, and I give it a height and scale. See, so that was much easier to do than having to convert the object to a polyline to create it. Let's do another press pull here. and done, right? So see, it's very simple to use that tool to start creating the geometry that we want. And that's what I want you to do. I want you to start practicing these tools and start creating the geometry that you need for the project that you decided to do. There are other tools that we are going to be learning as we move on, right? But these are the most basic ones that we need to have. Now, there are pros and cons also in using press pull or using extrude. Um, Press pull is called press pull because it actually has a couple of functions. For example, one thing I could do, and I'm going to go back to conceptual 2D wireframe. Maybe I draw a line here on this center point. And then one thing I'm going to do is I am going to actually make this face, the exterior face of this solid, the UCS. And so I'm going to go back here, the work plane. I'm going to select 3 point, select 0, X, and Y. So now the Y, X and Y is kind of vertical here. And now I'm going to do a rectangle. Maybe I have a wall where I want to create a door. So I'm going to do X going to be 30 inches, comma, and the height is going to be 80 inches. And that's the door. So right now, this is nothing, right? If I get back to the world UCS and turn back my conceptual, only thing I see is that line. But if I use press pull and I come closer to that line, I can see it's selected as the boundary, and then I can click and press. By pressing, then I can create an opening. And that's why the tool is called press pull. If I pull, it creates a solid. If I press, it creates a void. Let's backtrack and do that again. And this time I'm going to do a solid. And so I select press pull, bring my cursor close to that boundary, press, click, and then pull. And it creates a solid. So that tool is very dynamic in that it can do that. It can do press, creates a void, and pull, it creates a solid. And so try to see if you can identify uses for that particular tool in your projects. Obviously, you know, this is a combination of modifying the 3-point UCS, the UCS using the 3-point tool, and then creating a rectangle with the right sizes and so on and so forth to create the openings. And so that could be part of the workflow that we want to do um, in our project. Now, maybe you do that, or maybe not. Maybe the approach is different. Maybe the approach is to do this, for example. Now delete the whole thing. Oh, hold on, because I don't want to delete that. I'm going to undo. I don't want to delete. See, that's one of the pros and cons. Of the polyline. All right, so we're back here. Let's go back to the UCS and world UCS. So what happens if I do a press pull on this whole thing? First, it's hard to select it. I'm gonna draw a line here to enclose that boundary. But let's try. I'm gonna do press pull. And then try to click inside that boundary. It's hard because my cursor is completely, see, and so maybe I do a line here to kind of divide that. And then I get closer to that boundary, then do press pull. Now I have it, and now I type 8 feet. And so see, I can do that. I can do the whole thing right away. Um, that's one thing. So maybe that's something you can do also if the plan if the floor plan that you have allows you to do that, then great, then it's all good. And so we're going to see other tools that we can use as well to create the geometry. But for now, the use of the extrude and the use of press pull are okay. Remember to make sure that any time that you try to create this um, and to use 2D profiles to create 3D solids in AutoCAD, you are very conscious of where your UCS is. The UCS, the user coordinate system, defines the work plane. And the work plane for 2D is where the X and Y are, right? That's what we want to do. Remember that you can use your plan as the profile that you want to extract. And not only the plan, but you can also use your elevations. For example, I could say, okay, I'm going to extract an elevation. So maybe I go to documents and 130, and then I go to elevation and section. I don't have anything there. Maybe I do. No, there's nothing there. So I'm going to select a different drawing, XR, and do detach. So attach. And we'll look at somewhere else here. One sec. All right, so maybe I do this. I have elevation and section. And so I am going to bring it there. And done. Well, the first thing you can see is that I have this elevation, and this is the one I use in CAD 1. The elevation is kind of on the floor. And so even though I could use all the 2D profiles here to generate 3D solids, it doesn't work for me that way because I like to place it the right way. So I then should have the X and Y kind of standing up so that that's when I import that XREF. So let's try to do that so you can see how that works. So I'm going to change my UCS to be kind of on the face of this object, right? And so go to 3-point UCS, X and Y. Okay, now let's bring that XREF. Okay, and now that is there, you can see that it's kind of standing up. So now I'm going to go back to my world UCS. But because I brought this XREF when the UCS was located that way, then this drawing is now oriented that way. And so I could, if I have all the elevations of my building and they're well coordinated, I could place each elevation on each side of the floor plan. And then I can use the geometry to create. So for example, let me move these down here. And so now I could use this geometry here to create geometry on the solid that I have. Now, of course, this is a complex object and it's got there's a combination of many line work here. So that's why the computer is thinking, okay, which line am I going to use? But in your drawings,